In this lecture, we will learn about the composite design pattern and how to implement it in Python. Composite is a structural design pattern. It lets us treat individual objects and groups of objects uniformly. For example, think directories contain entries, each of which could be a directory. Like the folders on our computer could contain files or other folders, composite lets us treat folders and files the same to make our program simpler. We can also use the composite pattern to compose objects into tree structures to represent whole or part hierarchies. We use the composite pattern when we have to implement a tree-like object structure, or when we want the client code to treat both simple and complex objects uniformly. Let's look at the pros and cons of using the composite design pattern. The advantages of using composite are that we can work with complex tree structures more conveniently, using polymorphism and recursion to our advantage. Also, we can introduce new element types without breaking existing code. The drawback of the composite pattern is that it might be difficult to provide a common interface for classes whose functionality differs too much. Let's learn how to implement the composite design pattern in Python. We will start out by creating a class named component. Inside of this class, we will define an addChild function that takes in two parameters, self and component. Inside of this function, we will use the pass keyword. Then we will have a function named traverse that takes in the self parameter. Inside of this function, we will use the pass keyword. Next, we will create a class named file that extends the component class. Inside of this class, we will implement the init function that will take in two parameters, self and value. Inside of the init function, we will set self.value equal to value. Then we will create a function named addChild that takes in two parameters, self and component. Inside of this function, we will use the pass keyword. Next, we will create a function named traverse that takes in the self parameter. Inside of this function, we will print file and then self.value to the console. Next, we will create a class named folder that extends the component class. Inside of this class, we will implement the init function that takes in two parameters, self and value. Inside of the init function, we will set self.value equal to value and self.componentList equal to an empty list. Then we will define an addChild function that takes in two parameters, self and component. Inside of this function, we will call self.componentList.append and pass in component. Then we will create a function named traverse that takes in the self parameter. Inside of this function, we will print folder and then self.value. Then we will iterate over each component in self.componentList. We will call the traverse function on each component. Time to test our code. We will create a variable named folder1 and set it equal to a folder object with the string folder1 information passed in. Then we will create a variable named folder2, set to a folder2 object with the string folder2 information passed in. After that, we will have a variable named file1 set to a file object with file1 information passed in. Then we will have a file2 variable set to a file object with the string file2 information passed in. After that, we will call folder2.addChild and pass in file1. Then we will call folder2.addChild and pass in file2. Next, we will create a variable named file3 and set it equal to a file object with the string file3 information passed in. Then we will call folder1.addChild folder2 and then folder1.addChild file3. Finally, we will call folder1.traverse. When we run the code, notice the information for all of the files and folders was printed since they were added into folder1 and we traversed it. In the next lecture, we will learn about the decorator design pattern and how to implement it in Python.